All right. Hi, everybody. My name is Arash. I'm going to be talking about 3D printing today, and what stuff we can do with them. I have a bunch of 3D printed items that I wanted to show you guys, just so you can get an idea of what things can be done. 3D printing is used for many different things, such as prototyping, making little knickknacks, toys. They're being used in the medical field, of course. Some of you may have heard on the news about that. But it has a lot of applications to it, and it's definitely a good area of interest if you guys are curious about it. I do want to go through certain misconceptions first, just to clear the air out about 3D printing. Um, and feel free to chime in at any time. This is definitely an open discussion type of meeting. So please feel free to chime in. If you have any questions, I'll be more than happy to help you guys out. I can send you links, be in contact with me. This is definitely a passion of mine, so I do not mind helping out anyone that has any type of questions. I'm a beginner, or I was a beginner a couple years back myself. My main source was Google. You can easily self-teach it, but a meeting like this would definitely jumpstart you guys in the long run. So let's begin with some of the misconceptions. A lot of people think 3D printing is expensive. It actually is not anymore. It used to be maybe 4 years ago, but throughout the years, things have gotten cheaper and cheaper to a point where now you can get a very nice 3D printer for $200 to $300. So that's one part. So they're no longer as expensive as you think they are. I mean, yes, you can get ones that are $2,000. They even have them up to $100,000. Who knows? They may be it may be more expensive than that also. But I'm saying on a day-to-day type of 3D printing, what we can get is very functional and very good quality. They'll put out really good quality 3D prints, $300. Another misconception is the plastic is expensive, like the filament or the ink is expensive. It actually is not. You can get a 2 pound, or yes, a 2 pound filament pack, which is something this big, for $20 to $30. So, and that one, and I'll give you an idea. So this, for example, is a 3D printed item. I can maybe print 50 of these with one spool of filament, and that'll last. So they last a very long time. So for $24, so $324, you can literally get started 3D printing and be fine. So those are some of the misconceptions. Now, if you know of anything else, just in the chat box, go ahead and send it. If you have any questions, let you know. Or let me know. So here are some of the 3D printed items that you may see online. These are just pretty much, I call them like tchotchkes, right? So a lot of people have made the comments before the pandemic. We used to hold all of these events where people will come and see the stuff we 3D printed and everything, and they always would say, okay, so this is a $1,000 toy maker. And it's like, yes, you can see it that way. You can make a lot of really cool toys, really high details, as you can see. So yes, you can definitely do that, but you can also make other items. So this is like one of the prototypes I've been working on my, for my personal time. This is pretty much a microcontroller 3D printed case. These are all designed in home. So what you can do, there's some 3D softwares that are free and some that are that you can pay for. I used a software called Fusion 360. So this was all designed with Fusion 360. If you're familiar, I use the Arduino board in this, and I'm using servos in this mechanical or robotic arm. So pretty much you can program from this box, you can hook it up to these pins, and you can move the robotic arm using just different types of programming skills. So you can make a lot of actual functional items. If you are into prototyping, it is a very good tool. One of my favorite projects I found online was this robot vacuum, and I don't have the top on so that you guys can see. So a lot of people, when they design a lot of these different things, they leave them online for free as an online resource for people to just start making. It is really fun. It's a really open community out there. If you are new to it, you'll realize that very quickly. So somebody put this design out. What I did was I 3D printed the parts. I like electrical engineering, so I started tweaking. They left the instructions, so I started tweaking with the coding and everything, and made this robot vacuum that actually does function. It's really cool. Again, using the Arduino board. That's another thing. Not really 3D printing, but if you are into prototyping and making robots, making any type of sensory-based, some people, for example, use these Arduinos for making these home defense kits and all these different stuff. So it's a lot of fun. You can do a lot with them. So I found this online, ended up 3D printing it. It was a really fun project. It is still a work in progress. You could always add parts to them, add more sensors. This only uses 2 sensors here and a 1 bump sensor here. I don't know if you can hear the click. So yeah, so it's, you can make a lot of fun projects, and some of these, again, functional. These 3D files that are used to actually 3D print these, you can actually send these to manufacturers and have them mass produced. So this is pretty much the best way to start prototyping. Now, I've been into robotics as a personal hobby for a very long time, a very long part of my life. So I started off when I was a child, I started off with making robots with cardboard. And then I graduated, I became a little bit more responsible, graduated to wood and started cutting wood with saws and all of that. And then once 3D printing became more of a streamlined thing, I ended up getting into that, and it's fantastic. There's a good resource. Now, if you're writing down notes, a great resource was using this website called Tinkercad. They have tutorials on the website itself. You sign up for it for free, and it teaches you the basics of 3D designing. Once you're done 3D designing, you go to 3D printing. Now, 3D printing by itself is a animal of itself. You need to know a lot of things about it to get things right. So one of the things is, so again, we'll go back to this. So this was 3D printed on a Creality CR10. That's the 3D printer I have. I actually have 2 3D print, actually 3. This one was my first one, if you can see. So this was my first one, bought it for $400 at the time. But it's pretty much useless at this point, just because the new ones I have, I mean, they're a Cadillac compared to what I have now, or what I used to have. So anyway, so this was 3D printed on a Creality CR10. What happens is the 3D printer goes layer by layer. It starts from the bottom, so it starts melting the plastic, and it goes one layer at a time, and it starts caking them on top of each other. So that's how this was built. Now, one of the most common issues that 3D printers have is bed adhesion. What that means is where the print bed and this they need to get stuck to each other the best way they can. Because if it's not, the print head, as it's moving up, it could knock out the item, and next thing you know, you have nothing for a print. You just have a ball of plastic, pretty much. So so bed adhesion is one of the #1 things for 3D printing. You have to make sure your bed is level for the 3D printer. So now you're talking about like, okay, well, I don't know what that even means. So these are things that as you're working on a 3D printer, you'll start learning. Is again, it needs to be stuck really well. So when the print head, usually some print beds, what they have is a screw or 2 or 3 screws underneath, and you adjust them where the print head has to be very super close. Now what you can do is you can put a paper under it, and you can move it as you're turning the screw. Once the print head is close enough to the bed, the bed adhesion will be fine. You can use other things such as, they're called rafts. Rafts are what literally makes or helps this stick to the bed fine. Another thing is, you can see on the ear. So imagine if the printer is going up all the way. So these are all fine. Well, here, the printer head has to print up in the air because there's nothing above it, right? So it's going up. It has to print in midair. Well, what happens is these ears will start drooping down because as the printer is going, the plastic will just pour down. So what I'm trying to get to is you're going to need something called supports. Supports are these little things, these little pieces of breakaway plastic that ends up pretty much supporting the ears as it's 3D printing up. So all of this can be done using what's called a slicer. A slicer is pretty much a software. It has a graphical user interface, GUI, that helps us users be able to send a 3D designed model, make it into code, what's called G-code, and that G-code is sent to the printer. That's what language the printer understands, is a G-code. So pretty much G-codes is X, Y, and Z coordinates of the 3D design. So it's millions of lines of code. I mean, imagine X, Y, Z-ing this all the way from bottom to top. It's a lot of code. So the slicer ends up creating the G code. So that's just the technical part about it. So I use a slicer called Cura. It's a free to everyone software that you can download. They're compatible to hundreds and hundreds of different 3D printers out there. So pretty much what you do is you grab this design online. They're, again, available for free a lot of places. And another good resource, if you're writing down, go ahead and write this down. It's called Thingiverse. And I'll show these websites to you. So just if you just type it in, you'll see. I don't need to spell it out. Google would fix that for you. Thingiverse. So this website has a lot of developers that design these for free. They leave it available online for free. The only difference is that some of these, they end up copywriting, so you can't make this and sell it, for example, without getting their permissions. So you should get their permission, say, hey, I want to sell this, and I'll cut you in for 1/3, let's say, if you want to make a business out of it. So then they either agree or disagree, and some of them don't even have copyrights on them, and they just say, if you want to sell it, feel free to. They don't care. So Thingiverse, you find the design, you download it, and then you have this software, which is the slicer, called Cura. Cura you just upload to this or download it to Cura, and then you say slice, and once it slices it, it creates a G code, and you put on a USB and put it on your printer. Now, there's other ways to do this, but this is the most common way that I'm talking about. So that's the conceptual part of 3D printing. It's pretty simple, but what comes afterwards is the detail that you have to add, which is what I talked about. So you put it on your slicer called Cura. You say, oh, I want a raft. So I'm going to go ahead and share my screen so you can actually see exactly what I'm talking about. So this is my Cura slicer. Okay. So this is a bracket that I actually 3D printed last night. So right now, this is going to go layer by layer, and this is the, hold on, let me try to hide this. It's getting in my way. Okay, so in the preview, so it's generating a preview. See, it goes layer by layer, so you can move it up and down. This is a preview of when it starts 3D printing, okay? So now, let me move this around. So, so if you look at the difference, so this is the actual view of the item. You see how there's nothing here? These are called what's called an overhang. And when you select, so in the preview here, see there's an actual extra layer that is being here. So this is what the support I was telling you about. So it starts at very thin from the bottom and it ends up just building up on with it. So then it supports the overhangs of the 3D printed item, okay? So you do, and then and it's literally as simple as selecting it. Where is it? In the support section. So once you uncheck it and you click slice, see now it actually took that piece of plastic away. So it's that simple. So see here, like over here, as you can see, this part over here, see, it can't print that midair, right? I mean, you know, the laws of physics would not allow you to do that. So that's why you need something called a support. And then here, build plate adhesion. This is where you select if you want a raft or not. A brim, I never use it, so I'm not going to talk about it. A skirt is this little line. What it does is it pours the plastic out to make sure all the different colors you used from the previous time would be dispensed out. So then once it does a print here, it will be a clean print. So you can select it, and once you select it and click slice, it does it. And then the option it'll give you is you can print to your 3D printer or put it on USB. So it's simple enough, right? It doesn't take a rocket scientist to figure this out, but these are the resources that I figured out throughout years, and they've proven to many and many times that to be very useful. I have a daughter, so I 3D printed this lizard here. This was again available online for free. I can also actually, let me show you this also. So let's share my Thingiverse screen. So this is the website I was telling you guys about. So Thingiverse, so let's say I type in lizard. I just want to print a lizard. You press enter. And all these designs show up. These are, again, all free. I can't stress that more. You just click on it. You say, oh, I like this. I want to 3D print this. You click it. You say either download all files, or you can just go to a specific file and click download. So here, for example, let's say if I want the version, they have different versions. A lot of these designers end up remaking them. So you just say download, and then once it downloads, you just click on it and it would open it up in Cura, and then you save it to USB to go to your printer. So I actually want to show you guys my 3D printer in action. So due to the recent events, aka pandemic, I've been 3D printing face shields. So this is the face shield. So the white part is the 3D printed part, and then you get the shield. It's just see-through clear plastic, and you attach it, and it's useful. So as you can see, I brought manufacturing at home. I mean, that's really the direction we're all going. Is we're going to be printing more and more complex stuff. So we can manufacture everything at home. So this is one of my 3D printers. Right now, 3D printing one of those shields. So as you can see, it's doing it layer by layer. And believe it or not, one piece, because of the layers, one piece of this takes hour and a half to 3D print. So 3D printing is a very slow process. You guys remember that bracket that was on my slicer? So I 3D printed last night with orange filament, bought it for $19.99, I believe, and the filament. And so this is a pretty big part, and I made it very dense. You can change all those settings in Cura. So I made it very dense because I wanted it to be very strong. It's a bracket that is used actually to complement this 3D printer. But as you can see, it really didn't take that much. I mean, the plastic was up to here, made one of these just slightly less. And this is my bigger 3D printer. This is the Creality CR10. So it has a very big build plate, as you can see, and it goes all the way up. So you can 3D print a lot of cool parts with this. Some people use 3D printing for cosplay design. That's pretty much where people go and wear costumes. So you can see there's different designs available online. Like for example, for Iron Man suit, people design a full-on suit. Of course, it doesn't fly, but there has been people that have 3D designed little jets that actually would propel you off the ground, make you fly, pretty much. So it's really cool. And again, those were all 3D designed and 3D printed. Now we have different types of 3D printers out there. So this one just 3D prints using Hello, can you hear me? Can you guys hear me now? Okay, good. Okay, so where did you guys lose me? What was the last thing I said? I'll wait for somebody to type it. Oh, other types of printers. Oh yeah, so yeah, sorry about that. So there are other types of printers out there. The one I have is just a regular FDM printer that ends up printing with PLA plastic. There's other different, PLA plastic is very forgiving. So that means you don't have to adjust your 3D printer too much. And then there's another type of plastic called ABS plastic. ABS is super strong plastic, but that means your temperatures have to be a lot higher for it to 3D print. So like, for example, my 3D printers, the manufacturer says it's okay, you can 3D print ABS, but I found that that's not true. You have to have certain things like enclosures to keep the heat in, to keep the plastic stuck to the build plate. Different types of like drafts or different types of temperature change would make, let's say if you were printing something flat, it would actually start bending outwards because the difference in temperature would affect it while it's 3D printing. So those are the parts where you have to really be mindful of. So PLA plastic, I've been using PLA plastic for years now, and I haven't had any issues. Now, there are now, for example, in our Fab Lab at Nova, we have different types of 3D printers. One of my favorite ones is the Mark Forged 3D printer. That one can can 3D print in fiberglass or in different types of like Kevlar and stuff like that. So it's really cool. sorry, not fiberglass, carbon fiber. I don't know why I said fiberglass. It can print in carbon fiber. So I actually ended up getting trained by one of the Mark Forged people, and it was really cool. One of them actually pulled a flash drive out and said that they are right now, their company is designing the new Mazda. I don't know which Mazda, but they were designing the Mazda prototype parts, and it was literally one part that was a functional part that was supposed to be in the car. So that's pretty much that's where manufacturing and any type of prototyping, that's the direction it's going to, is using 3D printers. And you know, something like a Mark Forge, that's a $7,000 3D printer. So, but however, you can actually make fully functional parts with them and then send it to manufacturing. There are some companies that go straight from 3D printer and they sell products. So, for example, I showed this at the beginning. I mean, this is, yes, it's a cute little elephant, pretty cool color change. I had a special filament for that. But it's also a phone holder, right? So it can hold the phone, and you just for something fun. And people will buy this. I mean, and it's pretty solid. It won't break. So you can make a lot of cool, ready to go out items. Again, the face shields. They're very durable. You can make them differently durable by changing the infill. That's another term for the insides of this, if you want it to be hollow or if you want it to be solid. Of course, the more solid it is, the longer it takes for the printer to print. Again, I mean, this stuff is nonstop for me. I 3D printed this. I actually 3D designed this on Fusion 360. Again, it's a very useful tool, but it does take, Fusion 360 is not quite as open the software and start 3D designing. You have to watch a bunch of tutorials to kind of get a good hang of it. I'm still getting a hang of it, even though I'm teaching classes about it. So yeah, it's, for example, this, and you can really make these detailed. So I put these metal pins in it, but pretty much, so as you can see, once the servo turns, it makes the finger curl up. So, and these are all just built by these mechanisms here. So you can make a lot of articulating parts with these. If you're, again, robotics, so obviously this stuff is my interest. Another one is a 4-legged robot, again, Arduino board. I'm not gonna stop talking about Arduino boards. They're pretty awesome. So this a 4-legged robot. So pretty much what you do, you can program this to start walking. Yeah, so it's a lot of, and then again, the toys and the tchotchkes, of course. This stuff is available online. You find them. My daughter loves playing with these. So yeah, so if you guys want to just do it for personal, for business, whatever, it's very, very useful and functional, and of course affordable. Now, 3D printing, I don't want you to think of it as a regular printer. It is not. It's a hobby. It's a skill set. Once you enter it, I mean, you just jump in this rabbit hole. You learn so much. I've joined a few Facebook groups, just called 3D printing Facebook groups and all that. So I've joined a few groups, and you can tell. I mean, once you buy a 3D printer, you're gonna have so many questions. Some of these I'm of course addressing right now, so you would be ahead, and these are the questions I have myself, right? So I try to narrow it down as narrow as I can, so that you can just get the information you need to make a decision on if I want to buy a 3D printer, or is this worth having. It absolutely is. If you're a maker, if you're an artist, there's fashion shows that are being done by them now, by people now, that use 3D printed parts. You can 3D print shoes. You can 3D print flexible items. Doesn't have to be stiff plastic. There's different types of plastic out there that are literally like a rubber duck. Like there's people that are 3D printing rubber ducks. That's how flexible they can be. So it definitely is a very functional piece that I personally think a lot of people will have in their homes in no time. I mean, right now they're making 3D printers that are fully automated. Now, those are the more expensive 3D printers, of course, that does the bed leveling by itself. It does all of this stuff I told you about. It does it all by itself. So you literally plug it in and it will start 3D printing stuff for you. So there are many options out there. We have a $50,000 3D printer at Nova Fab Lab. The $50,000 one. Now, what that does is, you know how I talked about the supports? Well, imagine if, let's say, you're building, you're prototyping a jet engine. There's going to be so many little parts that is going to need all these supports under them, and breaking them off, sanding them, it might be a very, very time-consuming thing, sometimes impossible. So what the $50,000 one, what that does is it has dual head extrusion, meaning it has not just one print head that melts the plastic, but two. So that means is one of them is melting a type of plastic that dissolves, and the other one is the one that's the main item. So you just put it in like this little bath, and the bath ends up, it has this type of chemical that breaks away all the support parts. So literally you put it in there, it shakes it, it looks like a French fry fryer, pretty much. You throw it in there, it's a basket, and it ends up vibrating it, where those pieces would just fall off after half an hour. So there's so many different types. Again, if you want things to make these, or things to make a new robot vacuum that you have a design for, then yes, you can buy a $300 3D printer and get that going. And you can print, again, in high detail. I mean, these are, once you become more immersed with the 3D printing world, there are certain things that you're going to catch on. One of them is print quality. The quality is when you cannot see the layers. Now, on this, I made this, the quality of it is very good. So you can change the quality of it. It takes a longer time, but you can do a lot of high details on these and make them very nicely detailed. And again, as I said, artists use these. They can do sculptures with them. Mechanics, not mechanics, well, maybe mechanics, but oh, actually, you say that, so I said mechanics. So one time, one of my car's visor, the little part broke where it made it rotate. Well, what I ended up doing was I 3D printed the part. I actually 3D designed it, 3D printed the part. Instead of ordering it online, waiting for 7 days for it to arrive, I 3D designed and 3D printed it. It took me maybe like 2 hours to get it done. So it's really cool, and I still have it in my car. So you can bring in-home manufacturing in your own house while you need parts for them. And let's say if you have a Honda Accord, you literally can type that in the Thingiverse website. And let's say a part that breaks the most, somebody end up designing a part and make it available, because they're like, hey, I know this part on this Honda Accord breaks all the time, so I decided to put this available for everyone. And all you do is you click download and print. So it's that simple. Again, it's a really fun world to be in, with, at least for me, with 3D printing. So and I know a lot of people now are becoming interested in the field of 3D printing because it's a hot topic, right? So we really can't wait for manufacturers to make us face shields, masks, whatnot. So now people at home are literally making these. I mean, I'm right now talking to you guys while the 3D printer is printing it for me. So you see, logically, I mean, it's just a no-brainer. You need it. So that is if you don't have one. Now, so pretty much this concludes my my talk and the stuff I've made. I mean, I've made hundreds and hundreds of stuff. So I'm gonna open it up to questions. If you have any questions on 3D printer recommendation, filament recommendation. Any questions if you're having issues with your 3D printer, any designs that you want me to send you a link to, please feel free, go ahead and you can write it in the chat box and let me know. Again, this chat box is private, I believe, so I don't think you guys can see the other people sending stuff. So go ahead and, I mean, feel free to ask me any questions and I'll read it out loud and I'll answer it. So I'll give you guys a few minutes. I'm just going to kind of ramble one question. Any laser scanning tools available to avoid design? Yes, there are. They're called 3D scanners. My best resource for that is just go on Amazon, type in 3D scanners and read the reviews. That's how I do my, I guess, research. So just read the reviews, see what the problems are. But yes, they're called 3D scanners. You can scan anything and then it will generate a 3D model of it, and then yes, you can 3D print it. Any way to edit an STL? Yes. Again, a good website is Tinkercad. That's the one I told you guys about where you can start designing CADs. That's the easiest one I found for editing STLs. Now, one caveat on that is that Tinkercad has a space limit. So, for example, I could import this, but if it was a more complex design, it actually wouldn't let me. It would say, "Oh, you can't do something bigger than this this amount of space or whatnot." So yeah, Tinkercad, that's what I use. I know you can do it on Fusion 360, but when I tried it, I mean, it's a pain. So yes, I would say Tinkercad. So, and like editing an STL is, let's say if you want half of this not be available, right? So you just want to do a half Baby Yoda and you want to put this on your wall, right? Like you want to put a hole or whatever. That's like the editing that you can do. Like you can cut off half of it from this way, put a little hole and you can hang it on your wall, or whatever, whatever you want to do. How about printing food items? There are 3D printers out there that do that. I know they're not, as far as I know, they're not available to consumers. Now, I could be wrong because, again, as we speak, somebody might put out something that already does that and put it for sale. But as far as I know, I don't see anything available out there for that. The material in which the 3D printer takes is very important. So you can't start putting, I don't know, like pancake batter through this and expect it to 3D print that for you, like 3D print pancake for you or whatever. But they all have different types of enclosures. So if you put the wrong plastic, you could permanently damage your item or your machine. So be sure to read the instruction manual and see what it can 3D print in.